Hi, I'm Lynch, and this is a full breakdown of my game, The Ones Who Feast. The Ones Who Feast is an RTS game with tower defense properties. Gather resources from the surrounding land to build up your defenses against the never-ending onslaught of the Ones Who Feast. The goal of this game was for me to show my technical ability and create systems that can interact with each other to create a way for the player to strategically think, keeping their brain engaged with the game. To achieve this, I chose an RTS game with tower defense properties, as it doesn't require as much level design, just simple layouts that provide different aspects of challenge to a player. This allowed me to focus more on the code and the systems behind it. Moving from personal goals for the game and going on to the goals for the player experience, I wanted to create a game that makes you feel like you're always on the back foot and you're standing your ground in a massive battle against hordes of enemies. As mentioned before, I wanted the player to be able to survive this battle if they have good strategy and can plan ahead. To help enforce this feeling, I created my game design pillars, these being Final Stand, Strategy / Engaging the Brain, Playable on Mouse, and Balance. The second pillar, being Strategy, is quite a loose term, but in this context it means creating systems where the player can express their strategic thinking and creativity to help overcome the first pillar. The third pillar, being Balance, is also quite loose, but it is in the context of balancing the systems of the game to make sure that Pillar 1 and 2 can function. The fourth pillar is for accessibility and being able to play more casually, as from research, majority of RTS and tower defense games allow players to only use their mouse to play the game, making the player experience smoother and more chilled out. To help inform my goals for the game, I've researched strategy and answered the question, how memory affects a player's experience in a core loop and how this affects their strategic thinking. I researched this question to help my design to form the second pillar. During my research, I explored topics such as what is strategy, what makes a good strategy, and what is cognitive thinking and its effect on a person's strategic thinking. To conclude my research, I came to the conclusion that strategy is the ability to accomplish a goal by analysing the surroundings of any situation. This includes positives and negatives, and then using these to form a short or long-term plan in order to achieve your main goal. I also concluded that cognitive memory is a person's direct ability to remember and use information in short and long-term periods, and someone's ability to use this affects how well strategy can be executed. Overall, interactive game loops help inform strategic thinking in video games in the way that they accompany all forms of time and interactions a player can go through to form a strategy. Memory lets you begin to conceptualize a strategy through sensory information going into the short and long-term memory. The way this research helps me design the core aspects of the game is that it made me realize I need a fifth pillar called memory, or more accurately, a foundation for the pillar 2, strategy. This is the most important pillar, so it requires good foundation. Memory is the key to allowing strategy to take place. When it comes to planning my core mechanics of the game, I made this mind map that contained the core systems and what would be contained in them. This helped me not only get a mental map of what I wanted, but gave me a solid starting list of what I had to do for my game. While the project was going on as well, I would make lists on all the tasks I had to do and estimate how long they would take. This is to help me keep track of my tasks, let me know what I would need for prototyping at a good level. It also helped me keep my mentality positive, as there were many tasks, but splitting them up seemed more accomplishable. Whenever I would tick a task off, helped me keep positive and not burned out from the project. The main mechanic of the game is the ability to summon units that help you achieve the goal of surviving against the enemy hordes. This system gives the player the ability to place down 3 types of units, all with their own functionality. When the player clicks on the headquarters, this is their main base of operations and the place they will be defending throughout the game. It gives them 3 types of unit choices. If the player has enough resources available in order to buy the unit, they can then place this unit on the map in any allowed sections. Before placing though, the unit will follow the mouse and can then be fully placed via pressing a left click and making that unit active. The way this system was created is that when the player presses on the button here, it calls a function called change placement state on a script called change object to spawn. Whenever I refer to a button in this section, I refer to this script and function. When the button is clicked, it selects a unit that has been pre-selected. It calls a function in the placement manager. This function is called check state. This does what it says and checks what state an enum on the manager is. The enum is called placement states. This helps control the process the code takes when spawning in units. Another enum the button affects is called ally unit states, also located on the placement manager. This is where all allied unit types are housed. The button is clicked, it changes the state to a pre-selected one on the button. This makes it so the manager knows what unit you want to spawn in. When the button is pressed, it changes placement states to spawn, which in turn calls execute, as check state is called afterwards. Execute is located on the placement manager and checks if the player has enough resources to spawn in the unit they want to. If the player has enough resources, it spawns in the unit using this script. The game object called obj_to_spawn is changed in the button script. When the unit is spawned, the placement state gets changed to placing. This calls a function called follow mouse on another script. This script makes the newly spawned object follow the mouse position. As this function is being called every frame, whenever the player presses a left click, it makes obj_to_spawn null and changes the placement state to nothing, allowing the unit to be free from the script and officially placed and active. Other actions that happen during this left clicking is the price reduction of the unit, adding that to the endgame stats, some particle effects and audio, along with making a unit active, allowing their functionality to start. After the unit has been officially placed, the placement manager resets to original state. Another option players have is to delete the unit, removing it from play. Say they don't want it anymore or they place a wall poorly, this will also give them back half the amount of resources that they paid for. The first placeable unit I will talk about is the miner. This unit seeks out a resource to go to mine and bring back to base, as shown in the background. The way this works is that when the unit is placed, a function called locate is called on start. This function checks what type the miner is based off an enum selected in the inspector. This then gets a public static list for the type of resource. So for this example, we will use iron and the iron resource. So when locate is called, it gets the iron list and goes through each game object in it, finds the closest one to the miner. It then changes the miner to the walking state and sets a vector 3 to the iron resource location. When the miner is in walking mode, it travels to the vector 3 value, which is the iron resource location. When the miner reaches this destination, it hits a trigger box saying it to a gather state and setting the nav mesh speed of the miner to 0 to fully stop its movement and prevent sliding visuals. This changes the miner state to gathering. When this state is active, a script called gather timer is called, which sets a float called current amount and adds it by gather amount times time.delta time. When current amount is more than or equal to max storage, the miner gets its original speed back and its state changed to transporting. It is important to note for this script, all the values are from the miner manager and are carried over in this part of the script. When the miner is transporting, it does two things. The first is that it gets the base.transform.position and sets it to a vector 3 in which the miner travels to. The second thing it does is turn on visuals for a backpack to visualize the miner carrying back the resources for some visual clarity and feedback. When the miner reaches the base, it drops off the current storage amount it has and adds it to the public static value of the game, in this case iron, then repeats all of this process again. The miners allow the players to gain resources passively while allowing for more strategic thinking when it comes to balancing how many miners they have in order to get more resources. The miners also inform strategy as the player has to protect them, which makes them think about unit placement and paths they can let the miners go down. Miners also inform Pillar 1 as you don't get resources from just existing. Get them yourself, making you feel like one crew operation and you aren't getting help from the outside. Miners can also help a player's brain not to get overloaded as they automatically do all of the tasks mentioned. All the player needs to do is place and protect them, not manage them as much, allowing more space for their memory to take the more important information in. The second type of placeable unit is the offense unit. These units are responsible for killing enemy units to help defend the headquarters. When an enemy unit walks into a trigger sphere attached to the offense unit, enemy gets added to a list as shown. This also sets the offense unit to attacking mode, which is on an enum on the attack manager. When the offense unit is in attacking mode, they call the function A_attack every frame. The attack script checks if the goon list is bigger than 0 as an extra safety check for the code. If this list is bigger than 0, a float called time gets +1 to its value every second using time.delta time. Also sets the current target damageable script to the first damageable object in the list. This is to make it so the offense unit always aims at the closest unit. It's important to note that damageable is a script which all the units which can be harmed and slain have on it. This includes the headquarters. It houses their health and armor values which act as their health pool for the game. I get damageable in the attack script here as the projectiles that get fired from the offense unit require the damageable script of the current enemy target. If time is bigger or equal to a float called attack interval, it sets time back to 0 and the code for getting projectiles takes place. Before explaining projectiles, time is set back to 0 to act as an attack speed for the offense unit. How the projectiles is spawned, I will explain later in a section called object pooling. But for now, all you need to know is that it summons a projectile and sets it to a predetermined location using this line of code. This basically gets a random vector 3 from a list and sets the projectile to that location. All the code below is to determine the damage the projectile does, and it adds it to a list on the offense unit to help manage the projectiles. Another feature the offense unit has is that if the goon list.count is equal or less than 0, it puts the offense unit to passive mode, making it not shoot projectiles and return to passive. This is so the offense unit isn't just firing into the abyss 24/7. The final feature the offense unit has is the ability to be moved around the map. If the player has the offense unit selected, they can press right click anywhere on the map and the unit will get the vector 3 location, and they will then travel towards that vector 3. When there, they will go back into passive mode. Offense units are helped to inform the pillars and require planning to use in their maximum value. For example, players need to be careful where they move and place the offense units in order to slay the enemy horde. The final type of unit that can be spawned in is called the defense unit. This consists of placeable walls that can help defend miners and attack units. These are here to help players protect areas of the map and slow down enemy units as they need to get through the walls first. It also helps the feeling of a massive battle taking place and the final stand pillar as you are standing your ground, refusing enemies to get past you. These units don't have any state machines on them as they purely stand still and are made to be beat up. However, where they differ is in their placement. Unlike the other two unit types, where a defense unit is spawned in, they snap to a grid and visually show a grid. This is so players can't make defense units overlap, and grid snapping makes it easier for defense units to be placed. The reason other units don't have this is A, because they move or can be moved, B, snapping to a grid for other type of units doesn't feel smooth and is not needed. For the defense units, there is one special type of unit called the tower. This is a combination of defense and offense. This unit cannot be moved like defense units, but can attack like an offense unit. It works by just having an offense unit inside and with some extra code to make sure it gets activated and selected properly. A script all of the placeable units share is the script called can't place and trigger. This makes it so units can or cannot be placed if they are within certain boundaries. The boundaries that they cannot be placed in consist of red cubes and when over another allied unit. When the unit enters a place they cannot be spawned in, the cursor also changes to a red cross. This is to prevent units from being placed in areas I don't want them to be, such as inside the headquarters or outside of map boundaries. The way this script works is just off an onTriggerEnter function and sets a public static bool to true or false, depending on whether the trigger was entered or exited. It is important to note that the bool only changes if what entered or exited the trigger has the interface can't place onto it. The static bool that gets changed is used on the placement script, object follow mouse, and if it's false prevents a left click from working and therefore the unit cannot be placed. The walkers are the enemies in the ones who feast. They seek out any allied unit and go to kill them. This includes the headquarters. The way they work is that when they are activated, an enum called goon state gets changed to the walking state. This calls a function called locate allied units. This function accesses a global list called allied list. This contains all of the allied units such as headquarters, miners, offense and defense, only the ones that are currently placed and active in the map. When the walker has found the closest allied unit, it sets the game object to its target and sets the goon state into chase. When the walker is in chase state, they will move towards the vector 3 position of their target. For the walker to attack, it's based off a trigger box. When the target enters the trigger box, it sets the walker state to attack, calling the G attack function every frame. When this function is being called, it adds +1 to a float called time every second. If time is bigger than or equal to a float called attack interval, the walker does damage to a target. This keeps happening until either the allied unit dies or the allied unit exits the attack trigger, or if the walker dies as well. Some things to note about how the walkers operate is that whenever an allied unit is spawned, all the walkers will do their locate allied unit function again to make sure they are always targeting the closest allied unit. When the walker attack state is triggered, their speed is reduced to 0. This is to visually show they are attacking, but also make it so they don't perpetually circle around an enemy or clip through walls. The speed is set back to its original speed when the allied unit dies or leaves the trigger. There are also 3 types of enemies. The walker, which is the most common, with average speed and damage. The zoomer, which is smaller but has much higher speed with a little less damage than the walker. And then finally the tank, which is very slow and large but does lots of damage. This is to absorb some of the hits for other enemies, making them like small mini bosses to cause tension. My game uses a wave system to allow the enemies onto the map to seek out allied units and destroy them. The waves get increasingly more difficult as more enemies will spawn in the higher the wave is, using this line of code here and these values getting added to these. And depending on the threshold of waves reached, harder enemy types will spawn, such as the tank and zoomer walkers. The way this system works is that a countdown called _wave timer starts counting upwards, and when this time is bigger than or equal to a float called wave interval, the wave then spawns. Wave interval is the time it takes for a new wave to spawn in and acts as some downtime between waves for the player to buff their defenses again. Use to spawn is called. To help explain this code, we will use the walker enemy type as an example. There is a float called spawn walker amount. This has a base value of 10. Say we are on round 3 and this float now has a value of 20. The goons to spawn function will get 20 walkers from the object pool and add them to a list called toSpawnGoons. This will be the enemies that will spawn in on this wave. This is the code what actually enables the enemies onto the map and makes them active. So if spawn timer, which is a float going up by 1 every second, is bigger than the goon spawn rate, it will spawn a walker. What this does, it gets the position 0 in goons to spawn list and sets their position to a random predetermined spawn location on the map, and enables their game object, making their functions now possible. This keeps happening until the list goons to spawn is 0, and then the wave timer will be set back to 0 and the new wave will wait to be spawned again. A limitation I've set on this for optimization is that every goon that is fully spawned in and is added to a list called active goons. I use this to limit the amount of goons that are able to be active on the map. Using this line, this checks if the active goon list count is more than or equal to a float called max goon amount. If it is more than or equal to, it returns it, making it so no more goons are spawned in. Another thing to note is that when spawning in the goons, they are randomized using this line of code to make it so you aren't just getting walkers and then zoomers and then tanks. Each individual spawn is randomized, making it more unique. As mentioned before, one of the pillars for my game is being able to play the game with just a mouse. To help accommodate this, every action in the game could be used via left click or right click. I also created 2 different ways to move the camera, first being able to drag the screen. Another way the player can move the camera with the mouse is that if they go to the edges of the screen, the camera will move in the respective direction. Another system I have is the ability for the offense and minor units to gain experience and level up, therefore increasing all their stats. This is displayed in the stat UI, which I'll explain more after this segment. The way minors gain experience is by depositing resources into their headquarters. When they do this, they add experience to a float on a script called Level Manager. When they deposit, it also calls a function called Level Check. This does what it says and checks if the minor's current XP is bigger than the float value called 2 level up XP. If current XP is bigger than 2 level up XP, the minor then levels up, gaining a plus amount to their stats. 2 level up XP also gets times by the difficulty values set in the main menu. This is to make the levels increasingly harder to obtain, balancing more out in a longevity run. This also happens for the offense units, but instead of depositing resources, level check gets called whenever they slay an enemy and it is removed from their list in these lines of code. I made this system to feel like you're being rewarded for staying alive, and for balancing it means I can make units cost a bit more because I'm making units stronger the further they get into the game. This means the player has less offense units, but they scale an appropriate amount with the game. This forms pillar 1 as less unit gives more of a final stand feeling. As mentioned before, UI is a big part of strategy games, and they tend to be very information dense, so it's important to be able to display all of this information neatly and properly. From feedback from earlier prototypes, it was more apparent that I needed a lot of visual clarity of what everything is instead of just cubes and words/numbers with no meaning or icons. When it comes to the UI for the resources, there were several things I added. I moved the values to the bottom of the screen instead of the top, as I felt it was more suffocating at the top compared to the bottom. I kept their unique colours, however I added icons for each resource. I also made it so when you hover over the icon, it tells you what type of resource it is, along with some brief information on how to use it. I also changed the resource visualization. I made them more unique. When a miner goes to deposit the resource, leaving it, you can visually see one of the resource pots being taken. As mentioned in the miner section, I also added a backpack so it's clear when they were travelling back to headquarters. I also gave the particle effects for when they were mining to make it more clear that they were gathering resources. When the miner deposits his resource at their headquarters, they also flash the value added above their head. Visually, the waves mostly stayed the same, but moved down to the bottom, and I added a current wave along with a countdown to the next wave. Major changes were made to the visual aspect of spawning in units. At the start of prototyping, they were on the right hand side and took up all of the screen. You need to scroll in order to access the different types. This then got changed to where if you pressed right click, it would activate the UI in that position. Then you could select which unit type you wanted. This, however, wasn't always centered and took up a lot of screen space and important playable areas that would improve gameplay if they weren't blocked. This way of doing it also felt clunky to use. The final version of this was putting it in the bottom of the screen with these new fancy icons and names, and then when a player clicked on the button of the respective allied unit type, it would take them to all the possible units that can be spawned for that type. This felt a lot nicer to use, visually looked way better, and gave a lot more clarity on what was happening. It also meant you could see all the player space without feeling cramped. Another major update to the UI and making sure the player feedback was exceptional was adding something I call Stat UI. When a player clicks on any of the following: headquarters, miners, offense unit, defense units, and an enemy unit, it brings up this new menu at the bottom of the screen. This new canvas displays all the relevant statistics for that unit. This includes the image of the unit, the name of the unit, the health of the unit, and the health is also shown on this red circle here. It also shows the armor of the unit. The next stats vary depending on what type of unit is clicked. Miners show move speed, storage amount, and gather speed, whereas offense units show attack damage, attack speed, and attack range. Defense units just show armor and health. Enemy units show their attack speed, attack damage, and walk speed. Here's a full visual of all the types of icons I created for this system and what they stand for. To help players understand this, I made the icons as distinct as possible and tried to match them as best as I could with all of their meanings. I also made it so you can hover over the icon and it displays their name and the information about the icon and what it represents. This system helps players get a better understanding of all the strengths and weaknesses of the units they have, having more in-depth strategic thinking as they know more information and can play with this information. The visual feedback of this as well just shows what each unit does and how it is used. Another thing I did for the UI was gave everything images and icons. A lot of these have already been mentioned. People can respond and analyze photos faster than a bunch of text. It also means players can learn these icons and quickly decipher what does what, making their user experience much more responsive and smoother while playing. It also means I don't have a ton of meaningless text roaming about the screen. Some more visual clarity I gave is that when you hover over any unit, it shows a health bar, which represents their health. This is to avoid them being active 24/7, as that would get cluttered very fast, but this also allows the player to see health values without having to left click on each individual unit. Some more visual clarity I added was that the units buttons in the placement system get grayed out if you cannot afford them. This is to prevent players getting confused when they cannot afford a unit. On top of this, I also made it so when you hover over any of the buttons, it shows the name of the unit, information about them, but also how much they cost to help inform the player. To help the player understand when an enemy is getting hurt, I added a script onto projectiles to making it when it hits an enemy, it changes their material for 0.1 of a second, simulating that they got damaged. They also get a hit effect from the object pool. The enemies also get a small amount of force applied to them to simulate them getting hit by a bullet. There were several things I iterated on during my development process. These were based off testing feedback, abiding by the pillars, and optimization. Some of these have already been mentioned, such as the major UI overhaul. A change I made to help with the performance of the game was adding object pooling to my game. This is where you spawn in objects before the player fully loads the level, then this means you can teleport these objects in and activate them, instead of instantiating, which is very costly. The way this was achieved was firstly adding a loading screen for when you pick a level to choose. This code preloads the level, letting objects spawn in, and when they are fully spawned in, the player is then taken to the level. When it comes to setting up an object pool, I used a for each loop and had a preset float which acts as the spawn amount, then added these to a list, for example, projectile list. Then where I would normally instantiate the projectile, I use this section of code which gets the first unactive game objects in the list. Then I set its position to the spawn locks in this case, then making all the required things active, including the game object, in order to get its original functionality. I did this object pooling for the following: projectiles, all enemy types, the corpse system along with blood, and hit effects. I did these ones as they were instantiated at a very high rate, causing a lot of lag to take place. It's important to note that for this to work more efficiently is setting the game object active state to false when they are slain, instead of destroying the object. The first one being that the object pool can then reuse this object The second reason is that destroying a game object is also very costly. One of the ones that have not been mentioned is the change to the wave system code and functionality. The wave system used to instantiate the entire wave at once, then the countdown for the next wave would start. This was incredibly inefficient and would cause the game to lag tremendously, as around 100 enemies will not only be instantiated, but then also call all of their functions at the exact same time. But I changed this to the previous system that I explained. Change I made to the game was removing an allied and enemy unit called a buffer. These units either gave speed, damage or health regeneration buff to nearby allied or enemy units. There were two reasons for removing this. The first one being it didn't help inform Pillar 1, as being able to buff units in a large radius removes some of the scariness of being overwhelmed by the hordes. It also means units don't grow exponentially with their time alive. It felt extremely hard to balance, as too little buff amount made them useless, but then too much made them very strong. Either one not getting perfectly balanced. So instead of having physical buffers you could place, I then opted to do the level up system instead. Basically buff themselves over time instead of straight away like the previous ones. It also gave the players less to do and manage and let them focus on other units and not clog up as much memory. Some other small changes I made based off feedback was to help abide to the pillars, this being adding defense units. Another thing I added was a 3-minute timer to get your defenses built and ready. This has two purposes. The first one being it helps the player with the final stand feeling as you buffer your defenses to hold the line, but it also gives the player enough time to plan out what they want to do and let the player gather resources and do some unit management before the waves start coming, abiding by Pillar 2. When it comes for what went well for my game, I say that the pillars were followed very well, and this helps inform the calm gameplay loop and the feel of the game. Setting these pillars up and setting up my overall goal helped with the way I coded and what I wanted to code in the first place. I also believe the visual feedback of the game is great, especially for a very information dense genre. This in turn also helps the player strategize, as they can take in more information easily and know what everything else is or does. I am happy with the level of performance you get for a game with horde elements. When it comes to areas of improvement, I believe colours were quite difficult to nail properly. In the future, I think making the models slightly more detailed at the start would help with the colours and visual feedback, but also to remember to make it so colours don't clash or cause a lot of visual clutter, like I had with the corpse and blood being the same colours, as not only the enemies but the health bars had this red colour as well. Another thing for future improvement will be making the code slightly more future-proof down the line. I understand code will always be changed in the future, but some of my code had to be revamped depending on the situation. I did some of this well, but I would take much more time to properly plan out each individual step of code of the structure. Thank you for taking the time